Alright, so today we're going to start talking about the parabola and look at its way of fitting into the conic sections. We've already looked at the two cones and everything and how the parabola is formed. But let's look at the algebraic part of it and also the graphing part of it. Alright, here is a summary of what you should already know about graphing parabolas. Graphing y equals a times x minus h squared plus k, and y equals ax squared plus bx plus c. These are the two major forms that you're going to see this thing in. We know that x squared means that we're going to have, if it's the highest degree, we're going to have a parabola for it. And bx is going to be a shift or a sign of a shift in some direction. Now, if a is greater than 0, the graph is going to open upward. And if a is less than 0, then the graph opens downward. Now, the vertex of y equals a times x minus h quantity squared plus k is hk. Pull that out of there, change its sign, and the k is just the sign that it normally would be. Now, the x-coordinate of the vertex of y equals ax squared plus bx plus c is x equals negative b over 2a. So that's how you can find the x-coordinate of the vertex. That little equation right there. And the b and the a are coming out of the coefficients here and here. So that right there is something that you should, if you have not already, remember. X equals negative b over 2a. Don't forget the negative. Now, parabolas can be given a geometric definition that enables us to include graphs that open to the left or to the right, as well as those that open obliquely, in other words, on a slant. The definitions of ellipses and hyperbolas involve two fixed points, the foci. By contrast, the definition of parabola is based on one point and a line. That one point, of course, is going to be the focus, and the line is going to be what's called the directrix. And here's a drawing of it right here. And here's the definition. A parabola is a set of all points in a plane that are equidistant from a fixed line, the directrix, and a fixed point, the focus, that is not on the line. Now, what that means is this. If we go and we measure to any point on this parabola, and we measure the linear distance from that point to the vertex, and we measure the perpendicular distance to the directrix, this has to be perpendicular, then these two lines are going to be the same length. They're going to be congruent distances, or equal distances. And that's going to be true for every single point on the parabola. That's the definition of a parabola. So it's all based off of distances from the vertex and the directrix. Now we're going to find exactly how that equation tells us what this distance from the vertex to the focus actually is. And I think I said vertex just a second ago. It's based on the distance from that point to the focus and the directrix, not the vertex. The vertex is a point on the graph. These two things are not part of the graph, they're properties of the graph. The actual graph is all these fixed points, or sorry, all these points in the plane that are equidistant from the vertex, sorry, said it again, from the focus and the directrix. Now, one thing you got to remember, when you're measuring from a point to a line, you're always going to measure the perpendicular distance. Otherwise, we could go and we could have this distance or this distance or all kinds of other distances. Perpendicular distance means we're going to have one distance from a given point, not an infinitely many different distances that anybody with their, an idea could come up with. So that is how we have to always measure from a point to a line. Now, the standard forms of the equations of a parabola with vertex at the origin is y squared equals 4 times p times x, or x squared equals 4 times p times y. And this is depending on which way it opens. If the y is squared, it's going to open side to side, either to the left or to the right. If the x is squared, it's either going to open up or open down. So whichever one is squared is going to be the opposite one. It's going to be in that opposite direction that it's going to open. For instance, y is up and down, but I always remember that if my y is squared, then that means it's going to open left or right. My x is side to side, but if my x is squared, that means it's going to open up or down. That's just my little memory tool for remembering. You can use it or not, doesn't matter. So this is y squared equals 4px. This is x squared equals 4py, a general form for it. Now, with each of these, depending on p, if p is greater than 0, it's going to open in the positive direction. In other words, to the right. If p is less than 0, it's going to open in the negative direction, to the left. Same thing over here. If p is greater than 0, it's going to open in the positive direction, which is up. And if p is less than 0, it's going to open in the negative direction, which is down. It all depends on which way we're talking about. Like, for instance, here, with this one, we know it's left and right. Well, right is positive, left is negative. Here we know it's opening up and down. Up is positive, down is negative. So that's depending on the p. Now, one thing you need to think, and we don't really get into the dimensions here with these graphs just yet, but it's helpful to think of p as a directed distance from the vertex to the focus. So if p is greater than 0, the focus lies p units to the right of the vertex or above the vertex. If p is less than 0, then the focus lies absolute value of p units to the left or below the vertex. And you'll see that in just a second. All right, so find the focus and the directrix of the parabola given by y squared equals 12x. Then graph the parabola. All right, so we know the center, the vertex. We don't have a center here. Vertex is going to be 0, 0. We can go ahead and plot that. Now, is this going to open up and down or left and right? Well, remember, y squared, that is, y is up, so this is going to open left and right because y is squared. So it's going to open side to side. Now we need to find out what p is. Well, remember, this form right here is y squared equals 4px. So taking out the x, we know that 4p equals 12. Which means, of course, that p is going to be positive, so that means it's going to open to the right. And p is going to be 3. So what the directed distance means is that since we know it's opening left and right, or specifically in this case to the right, we're going to move 1, 2, 3 units over, and that's going to be the focus. Now, in the same way, since we know that p is 3 units in this direction, the directrix is 3 units in the opposite direction. So at -3, we're going to have, let me get my line tool here, we're going to have a dotted line. So this is, remember, not technically part of the graph, but it is a property of the graph, and it's going to be a way that we would build the graph if we were going specifically according to the definition of the graph. And then, of course, this thing is just going to open to the side. Now, we're going to find something in just a second that's going to go across here at the focus, and it's going to give us an idea of how wide we need to make it. Right now, we don't know that, but we're going to talk about it in just a second, that will actually add to our accuracy with our graph of parabolas. Because I'll be honest with you, looking at your guys' parabolas, some of you just make a simple U. Remember, this thing is going out. It's not just going over and getting level. It'll never have a slope of 0. It's always going to have a positive slope on this one and a negative slope on this one. So it's always going out away from that middle of the graph. All right, now here is what I was just talking about. It's called the lattice rectum. The lattice rectum of the parabola is a line segment that passes through its focus, is parallel to its directrix, and has endpoints on the parabola. Figure 9.33 shows that the length of the lattice rectum for the graphs of y squared equals 4px and x squared equals 4py is the absolute value of 4p. So whatever the length of p is, or whatever that thing you're multiplying by the value is, that's going to be the width from one end so from one side of the parabola to the other. So with that last problem we were just looking at, right here, if 4p is 12, this thing should have been 12 units apart. So what we would have done is through the focus we would have gone 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, and our parabola actually is supposed to go through those points. So as you can see, we will 9 times out of 10 usually make this parabola too narrow. And you're going to be able to notice that when you start using the lattice rectum to see just exactly how far out that's going to be. So in 3 units it's gotten that wide. So that gives you an idea of how it works. Alright, so find the focus directrix of the parabola given by x squared equals negative 8y, then graph the parabola. Alright, so once again we know the vertex is at 0, 0. We can go ahead and plot that point. X squared means we're going to open up and down. Negative, or 4p equals negative 8, which means that p is equal to negative 2. So this is going to open down. So p is 2. Oh, sorry. P equals negative 2. So we're going to go down 2, 1, 2. Plot that point. There's your foci. We're going to go up 1, 2. And that's going to be where your lattice rectum is. I'm not going to do that in red this time. Let's do dash purple line. And I can't draw a strict line even with a line tool. How about that? Alright, so there's your lattice rectum. Oh, sorry, there's your directrix. And then we need the width of the lattice rectum to determine exactly how far out we're going to go. So 4p is negative 8, so we're going to go in each direction half of the absolute value of that. So absolute value of that's going to be 8, half that's going to be 4, so we go 1, 2, 3, 4, and 1, 2, 3, 4. And then we can sketch our graph. All right, and as we can see, having these points right here not only gives us an idea of how wide it is, but it's also giving us 2 more points to graph, which, you know, in itself knowing where those points need to go helps you to know and make a much more accurate graph. Now, find the standard form of the equation of a parabola with a focus 5, 0 and directrix at x equals -5, shown in figure something something. I don't know where the figure is, but anyway, that's all we really need. So if we go from the focus to the directrix, we go from 5, 0 to x equals -5. What's changing there? Just the x values. How far do we go from 5 to -5? We go 10 units. Take half of that. Half of that's going to be p, so that's going to be 5. Now, is this thing opening up or is it opening down? Well, if we've got a positive value here, that means it's going to open in the positive direction. Now, if x is changing on this, what do we know about the way it's opening? It's opening to the right, isn't it? We could even sketch this. We got x equals -5 here. We got a focus over here at 5, 0. So it would have to open sideways. So that means we're going to have y squared equals 4p times x. And, well, if we know p is 5, that means that y squared equals 20x. And that's all you got to do. Don't make it more complicated than it has to be. To find the equation for this, you need the vertex, you need p, and that's it. So if they give you enough information for you to be able to do some subtraction, find what p is, and know what the vertex is, then you've got the equation. Now, translations are going to occur when the vertex moves from the origin. And this is all you're doing. You're going to, as we have always done on all these conics, nothing changes with the figure except for where we start from. So once you get the vertex and know which way the thing is opening, it's real easy to add and subtract p in the correct direction. You just have to make sure you do. So take your time. Don't spend a lot of time saying that you can't do it, because if you can do those simpler ones that we just did, you can do these. All you do is you have to start at the vertex. So for instance, if I have y minus k squared equals 4p times x minus h, I know I'm going to start at hk. That's going to be my vertex. And then once I know what p is, I can determine which way I'm going to go from where it's opening and how far, and p being how far it needs to go. So I'm going to do h plus p if it opens horizontally, comma k, so I'm not moving up and down, I'm moving left and right, and then the directrix is going to be at h minus p. And the same thing is if it opens vertically. Don't make it more complicated than it has to be. Just find the new base from where you're starting and building from.